as it applies. My name is Gebbie. I'm the Vice President for Electrical Control and Instrumentation Engineering for DRA, and today we're going to be talking about the digital mine. Typical project cycle that we have, we start any project through from concept study, through pre-feasibility to definitive study, the design where I get really excited, and then obviously construction. Then a process of getting ops ready where we have a merge between the design teams and our operations teams. Commissioning, where we get to prove that everything works and stabilizing the operations, and then the operate and then optimization of what we've built. Digitization fits into this lifespan perfectly, but there are different requirements that we need during the process. So right in the beginning at concept, the question I'm asking our client, is digitization required? Does this fit into your dream and your requirements? Do you see a need for it? Some clients don't, but most of the clients that we've been interacting with in the last 18 months certainly believe that it is necessary and have embarked on that journey. I then want to know what the objective is of digitization. Is it just displaying information somewhere? Is there control involved? Which other systems are we likely to bring into play? I then want, as we move through the detail, I want to see the digital strategy that you as a client have. What are the outcomes that you would like to see? Questions I'm asking to myself and to my team are asking, what are the data sources? What piece of information am I picking up from all over the place? And then where do I need to deliver this information? Who are the consumers? What do they want to do with this information? Where do they want to see this information? That starts to then build into our design, and we start building a system that is ready for digitization. You don't see the benefits necessarily of the digital mine during commissioning. There's a number of systems that we'll use as commissioning tools, as part of our models, check sheets, but the value comes through the operation and optimization portions of the work. I'm going to now take you through a list, and you're going to see similar lists in similar presentations throughout the mines and mets. So I've been lucky I get in first, I think. This to me is the dream list that I would like clients to have looked at and said, yes, this one I want, no, this one is not applicable to me, or it doesn't interest me. It helps me to define what the data sources are. So first one, value chain optimization. Now that can mean multiple different things. Where we're seeing this applied is by using geometallurgical data. I know what we're mining at a particular time. I obviously know the grade, but I also get to now know, is that rock particularly hard? Is it soft? Has it got extra impurities? Am I mining a lot more waste than reef in that particular place? And we can now start planning ahead. Yes, the flotation cells are going to use more reagents. I better start buying more. It talks to supply chain optimization. The crushers are going to be working harder. My efficiencies are going to drop. I can start tracking what my equipment pieces are going to be doing as these different ore bodies come through the plant. And then one that is of particular interest to me, feed forward control. I can start tuning the plant slightly differently to accept these different ore bodies coming in. Then changing tack a little bit. And COVID's had some advantages, unlocked a few opportunities for all of us. Because we couldn't travel, we're seeing a lot more interest in monitoring plants remotely, and then using particularly process expertise that we would have taken to a site, we can now access remotely through the digitization platforms that are available. So we are seeing process engineers, although they're still sitting behind their desk, providing expert advice to mining clients, looking at the operations, raw data, and we're seeing that particularly in the milling space at the moment. Real-time data streaming, tracking performance with notification and support, tied with the next item, live dashboards. We're seeing this as the first value for digitization, providing information to consumers outside the control room environment to make decisions and to monitor operations. And then the future for me in digitization is artificial intelligence applications coming down the line, five years down the line. I think this is the start of that journey. A lot's happening in utilities and asset management, machine telemetry, predictive maintenance, condition-based monitoring, all very similar items, having a lot of sensors on pieces of machinery and giving warnings of failures, predictions of when to do maintenance. We just finished a cooperation in the east of the country where all machinery there had vibration temperature monitoring throughout, feeding back into a system like this. When we design a plant, we start off by building a 3D model indicating what we're building, where things are, and as a design tool. I design all our instrumentation electric systems using a platform like COMOS. We have a few that we use. There is a model of all the wiring, for example, on a mine. These models are available to you as clients to use for training and then for the ongoing maintenance of the facility. And we're starting to see more and more use of process simulation tools. This was started 15 years ago, but now we're seeing those tools have developed to a point where it's fairly quick to build the process model and gives a lot more process insight into what the operations are doing. GPS technologies and locating, tracking assets. Most operations at the moment, if you look at any of the mine vehicles that are operating, there are tracking devices on those, monitoring driving, monitoring processes. And again, by applying sensors onto those devices. We're seeing a shift in health and safety, where at the moment, if I've got a safety incident on a particular operation, unless someone particularly phones me, I don't necessarily know about it. There's a possibility now through digitization that I'll have live information. Has been an event, I can start deciding how I want to react to it. Again, with those models that we've discussed, training, these are a great training tool to take new folk that have never been into a mine and walking them through so that they know what to expect. We're seeing a lot more use of wearables coming through. We're about to start rolling this out in an operation in Lesotho. Underground communications has changed dramatically with the network infrastructure, so leaky feeders are being supplemented with VoIP, with Wi-Fi based communications, and then the ability to have real-time safety data that I mentioned at the top of the list allows me to start doing some predictive analytics live. Yes, I've seen my incidences pick up. I need to be a lot more vigilant. I'm expecting something to happen. We can start rolling out a number of additional safety campaigns. A lot of the systems that we've been talking to will tie back up into ERP systems, particularly on the procurement side. From an engineering point of view, we actually focus primarily on the data lake. You'll see another slide coming up into this, getting that infrastructure in place, making the data accessible. What happens to the intelligence on that will come down the line. Dashboards that we've discussed already. We're seeing a lot more use of drones. We use drones in our reporting on our construction sites, but you can have autonomous drones, for example, monitoring a tailings dump. And we are seeing aspects of that coming through. Seeing a lot more interest in advanced process control again. Feed forward control, model predictive control, particularly with all this data available. multi-variable control and milling. We're seeing those coming back and being applied. A lot of visual systems coming through, looking at, say, the froth, bubble size and color on flotation systems. And then we will start seeing a lot more automation on vehicles, autonomous vehicles underground on the mining side. We're starting to see those conversations happening, and I predicted that will be coming a year or two down the line. Right. And then all of this ties back into supply chain. So if I'm talking to an ERP, I need additional spares, this we can start automating. What is the data lake system that we're looking at? Where is this data going to be captured? Is it in a OSPI system? Is it in one of the Schneider products? Is it one of the Rockwell products? Siemens also do a range of these systems and other vendors as well. And then of course, where does this data go? Do you want to access it in a cloud? What does that mean? And vitally, what is the security around that? So for me, practical considerations that need to be considered, as I've just mentioned, very, very important. Security. Who can get in? Who gets access? Who gives control and access? This needs to be considered right on early on in the process. Then I want to use this opportunity to highlight a big concern that we have in the industry. Ethernet is not all the same. I see many folk planning, I'm going to connect this with Ethernet, I'm going to take data from here, and merge it all into one network. Yes, you can. I don't always recommend that you do. The Ethernet-based automation tools that we use, like Profinet, like Ethernet IP, are not the same, although they interconnect with the Ethernet that you have in the office. It gets quite stressful when your operation suddenly just goes stop and you don't know why, and it's a network issue because some of these systems don't interact the way you anticipate them to. Some of the Ethernet systems that we're using are time critical. If I've got a level control controlling a valve, these days that'll be done over Ethernet, Profinet, Ethernet IP, Modbus TCP IP. I don't want that to fall over when we've decided to move a large video file across the same network. Those network designs are very, very important, and so you're seeing this merge between IT and the automation world and the overlap that brings. The system must be reliable, and if there are faults, and there are always faults in the world, they must be traceable. So when the plant does trip for whatever reason, I can pinpoint where the problem is and I can get it resolved quickly. I don't like the phone calls from the mine manager saying my plant stopped and I'm not sure where it's come from. All of this feeds back into the network design that you need to do. And then the design that we do needs to be constructible. We've had cases where we've planned particular underground infrastructure only to find that the mining plan has now been changed and that particular haulage is no longer available, and suddenly we're redesigning networks on the fly. So whatever we build must fit in with the timelines on the mining operations. Right, I've touched a number of different subjects. You are welcome to contact me or DRA if you want to discuss this further. And I'm hoping I've given you some food for thought as you go through the rest of the conference, and enjoy it. Goodbye.